So, hello everyone and welcome back to another episode of our MATHFLEX. So, for today's lesson is actually a continuation of our Parabola series. So, this time we will be focusing on two words which are commonly encountered when we deal about parabola. So, this time we have the directrix and focus. So, actually we had a short discussion of them on our episode 70, but this time we will be having a more detailed explanation about directrix and focus. So, directrix and focus, so as we go back to the definition of parabola, so it is a locus of a point which moves so that it is always equidistant from a point called focus and to a line called directrix. So what does it mean by that? So say for example, this is your focus, point focus. From your focus to your vertex, we have a distance A. Say this is distance A, and then from your vertex to your directrix it is equidistant to your focus to vertex. So the distance from your directrix to vertex and the vertex to focus are equidistant. So in other words, again, if you would select any point from your parabola, say we choose this point. Say we choose this point here. So if you'll try to connect your focus to that point, say this is distance D, okay, and from your from this point to the directrix, okay. So this is equidistant. So the distance is also big. So bear with me. These are not drawn to scale, but the concept is like that. So you can choose any point from your parabola. This point. So from your focus to this point, and then from this point to your directrix, are always equidistant. To better understand or to better explain further, so let's try some examples involving directrix and focus. So let's go. So let's try this example. So we are asked to find the focus and equation of the directrix of this parabola y squared is equal to 16x. So again, I saved this standard equation so that it will guide us on how our parabola will look like. So given the equation of the parabola, say, so for example, on this one, y squared is equal to 16x. So definitely our vertex will be at 0, 0. Okay, since it falls under this standard equations, and then I think our parabola is opening to the right, since it is somewhat like this equation, y squared is equal to 4ax. So let's try to draw our parabola. So this is our Cartesian coordinate system. So we have y-axis and a-axis, x-axis, sorry. And the vertex is at 0, 0. So vertex at 0, 0. And the parabola is opening to the right. So let's try to draw. I will try to draw the parabola as symmetrical as possible, but that won't be achieved, I think. Okay. So say for example, this is our parabola, which is y squared is equal to 16x. Since this is our parabola, it's opening to the right, so our focus is located somewhere here. So focus, okay? And we have the directrix on the other side of our parabola, okay? So we say that from vertex to focus, the distance is A. Right? So therefore, you have the standard equation here, which is y squared is equal to 4ax. So to find the value of a, since this is the same, x here is the same, so we can equate 4a to 16. So 4a is equal to 16. Therefore, your a value is equal to 16 over 4, which is equal to 4. So A now, the distance here, okay, from vertex to your focus is A. So that means your focus is located at, since this is on the x-axis, so your y-coordinate is 0, so focus will be at 4, 0. Okay? So we were able to identify our focus to be at 4, 0. Now, our vertex or our directrix is equidistant from your vertex to the line called directrix. So if I have this directrix here, back in the university, we always draw directrix in a dotted line. So using dotted lines, so broken line, sorry. So this is also equal to A. So this is from A, from focus to vertex is 4. So that means from vertex to the line is also, the distance is also 4. But this is on the negative side of your x value or x coordinate. So that means this would be the equation of this line. X is equal to -4. So that means our directrix has an equation which is equal to x to -4, or sometimes you'll make it x plus 4 is equal to 0. So it's the same. So again, to have more analysis of or understanding of this, let's have more examples. Okay, so let's have this second example here. So we are asked to find the directrix or the equation of the directrix given the equation of the parabola. So y minus 2, the quantity squared, is equal to -8 times x minus 1. So in this case, I think our equation or our parabola already in the standard form. So it's easier for us to identify the vertex. Vertex now, okay, will be at hk, so that means your h is -1 here, so the opposite sign, so it will be 1. And then -2 here, the opposite sign is 2, so your vertex can be found at 1, 2. So let's try to illustrate our parabola. So your y-axis and your x-axis. So vertex is at 1, 2, so that means 1, 1, 2. So this will be our vertex here. Okay, so where does our parabola open? Okay, so it falls under this, I think, y minus k squared. So you have negative here, you have negative there, so that means it's opening to the left. So our parabola is opening to the left. So somewhat like this. Okay, so this is our parabola. So that means if our parabola is opening to the left, okay, so your directrix is somewhere here, okay, somewhere on this side, because the directrix is always, the parabola is always at the back of your parabola. So it's the parabola is facing the focus, and at the back of it is your directrix. Okay, so how do we find the value of your or the equation of your directrix? So again, you have here y minus k squared is equal to -4a x minus h. So that means your -4a can be equated to -8. So -4a is equal to -8. So therefore, your a value is 8/4 or equal to 2. So in other words, from your vertex, okay, which is at 1, 2, so you have a distance from your directrix 2 units, okay? So from your vertex, that's 1, 1, 2. So that means your directrix will be this line. So 1, 2, so you already have 1 here. You already have 1 here, so that means another 2, 1, 2. So your directrix now will be at x is equal to 3 or x minus 3 is equal to 0. So that will be the direction or the equation of your directrix, which is x minus 3 is equal to 0. So this is your directrix. Okay? So let's have one last example. X squared is equal to 4 times the quantity y minus 2. So we have we are asked to find the focus and equation of the directrix. So again, our parabola, so it's if we will try to relate it on our standard equation, it's somewhat similar to this, a combination of this and this one. So that means our vertex here, let's identify our vertex. Since you don't have any variables there or any constant there, so we can have like the vertex, the x-axis on the x-axis is 0, and on the y-axis is 2. So let's try to draw our parabola. Okay. So vertex at 0, 2, 1, 2. So this is our vertex 0, 2, and where does our parabola open? So if you have like this x squared, so it opens up. So our parabola is opening up. Okay? So therefore, if your parabola is opening up, so that means your focus is somewhere here. Your focus is there. Okay? So how do we find focus? We say that the distance from your focus to your vertex is A, and from vertex to directrix is also A. So how we can get the A value? So from this to this, so we have here 4A is equal now to 4. So therefore your A value is 1. Okay? So the distance now is 1, so this is A. So that means your focus is located at 0. Since you already have 2 units from your origin to your vertex, so plus 1, so the focus will be at 0, 3. And your directrix, from your vertex to your directrix, is also 1. So that means your directrix is like this. So your directrix equation, so this is 2 minus 1, that is 1, so that means your directrix is equal to y is equal to 1, or y minus 1 is equal to 0. So this is the equation of your directrix. So the focus will be at 0, 3, and the equation of your directrix is 1, or y minus 1 is equal to 0. Okay, so I think these examples are enough to explain what is directrix, what is focus. So we'll be continuing our lessons on parabola on our next session. So meantime, this is what we have for today. I hope you will subscribe, watch of course, and hit the notification bell for you to get updated on our succeeding videos. Until next time guys, bye-bye! Lumipad, basang basa. Ayun, umiyak siya. Nigel, ayun, naku, taas niya, Nigel, sobrang basa pa niya. Hindi kaya Nigel, bigat pa ng katawan mo eh.